So I said we stopped at the point where we talked about color, and we'll continue talking about, we'll in general talk about symbology and cartography, but we'll start out talking about vector symbology. And we're all familiar with the three main types of vector shapes now from the first third of this course: points, lines, and polygons. But every map would be very boring and wouldn't really convey everything we want it to if you just could draw, if your map just had a circled little dot lines and polygons all look the same. So in GIS we have the ability to use symbology to change how points, lines, and polygons look. So here I have three different points on this map here. We've got a star, a circle, and a duck. That doesn't mean in GIS we don't actually, that's a point. Someone didn't actually go and trace the outline of the duck there. That's different in some CAD type programs. People do that, and that always makes converting from CAD to GIS a challenge, because sometimes we'll get a layer where they have symbology in CAD and I'll actually have to deal with there being a little duck-shaped polygon. In GIS we don't deal with things that way. We have a point, and then we can assign a symbol to it. So just from this alone, think of how much more I can convey about the differences between those three dots versus just having 3 points there. I can symbolize, say, which city's a capital, which isn't, the location of a bird watching site. I've also distinguished these three lines. I have a dashed line, a thick green line, and a hash line here. We'll talk about cultural norms. So I bet, what do you think that line depicts? Exactly, that's a railroad line. So we'll talk also a lot in this section about, wherever possible, adhering to cultural norms. That'll make your map easier to read. Bless you. I also have 3 different ways to symbolize a polygon or an area. I've got a swamp fill. It's got little icons indicating a swamp. Just a white shape and a yellow shape, but with a thicker outline. So these are all ways in which we can modify or change vector symbology. If you haven't, and I find this part of GIS interesting, GIS is a science, I think, in many ways, but it's also art. So if you're interested in the art side of this, you'll like hopefully this lecture. I like it a lot, and if you continue in geography, for those that aren't in geography, I would recommend the cartography class. It's offered in the geography department. I don't even recall who teaches it in which semester, but there's a cartography and GIS class typically offered in geography that will spend the whole semester on things like we're going to talk about this evening. And I find that course really interesting. I think it also helps your careers. We interview a lot of talented people. There's a lot of people out there that know GIS. Sometimes the tiebreaker comes down to who can make a nice looking, effective map, or for lack of a better word, a pretty map, versus someone that knows all the tools. They know the difference in union and intersect, and they know the 4 different types of remote sensing, accuracy, but struggle with making a nice looking map. So I think if you're pursuing a career in GIS, I've seen this myself, often the ability to demonstrate an effective understanding of cartography can put you over the top when you're competing with other candidates. To be completely frank, sometimes that's more important. If we need to have someone make a map that goes into an environmental impact statement, it's more important that you can make a nice looking map versus being able to tell me what radiometric, remote sensing is. Not to diminish the latter, but I'm saying in my experience, I've seen people really impress prospective employers by exhibiting good cartography. So if you make whether it's for this lab or for other classes where you use GIS, another tip would be, save some of your best maps from your classes or projects that you do into a portfolio. And when you go to the interview, bring examples of maps that you've made. That's another tip that I've seen really impress prospective employers. I know it does me and others in my group. To actually, rather than just say, I took cartography, I took GEO481, to actually come with examples. And that's another thing that might help you distinguish yourself from another candidate that might be of equal background. 2 things that I've noticed. Cartography involves a strategy of setting up symbols depending on your needs. But and this is, myself included, so easy to forget. You need to take a step back and say, why? Why am I making a map? It's probably not just for fun. You're making, every map you make is for a reason. What is the reason for this map? And that should be in the back of your mind throughout the process of making your map. Often, and we'll talk about this in a second, there's a key component to the map. There's one thing on the map that's most interesting to the reader. Everything else is background. So you need to make sure above everything, above all else, that that one thing stands out. And we'll talk a lot about that tonight. So that's why it's important to never lose sight of the purpose of your map. You could have two different people using the exact same data sets, but making two different maps for two different purposes. So those two maps will look very different, even though you're using the same data, if that makes sense. Because the purpose, the end goal of your map is what you should have in mind. This screenshot that goes along with that is just another example of quite a few variables of point line and polygon vector symbology. And some of this might be culturally or specific to the Western culture, and some of these things may be different in other cultures. But I think actually some of the things would apply everywhere. This is a good general strategy of warm colors, bad. We talked a little bit about this earlier this semester too. Cool colors, good. To really oversimplify this. So cool colors are green and red. Warm colors would be yellow, orange. So if you're making a map, I think I might be able to bring it up. I did the experiment with my daughter. I did that with you, didn't I? I showed her the map where Ohio was darker. And I said, what state is that? And everybody said Ohio. Remember that? And I said, how do you know which state I meant? And I just said, what state is that? Because all of you looked at the darker state and assumed that's what I meant. And you were right. That kind of illustrates the point that people gravitate towards the darker color, right? I did that to my daughter too. She's learning all the states, and she said the same thing. In that case, it was Texas. She pointed right to it and said Texas. Even though all the states were visible, I only had one state darker. So that kind of illustrated my point, is that humans gravitate to darker colors. So the areas that are most important on your map should be illustrated with darker colors. People also, and again, I think this is somewhat cultural, the other, warm colors, bad. Think of a map, well, even think of a traffic light. What color is stop is red. And go is green. I think that's a good thing to remember when trying to remember that for a test. If you're doing a map of environmental contamination, and this area is all in the clear, and another area has PCBs or some other environmental degradation, if you make a map where the good areas are red and the bad areas are green, you're going to really confuse your readers. Because people associate green with okay. Like green, go, red, stop. Even if you have it in a legend, people will instantly see the green areas and think, oh, these are the good areas. So that's another thing to keep in mind. And again, all of these things may be different, and I'll mention in a different culture where people may interpret colors differently. People also, I think I don't have it on this slide, I may have it on the next slide, they associate darker with more. This is that's Redlands, California, where USRI is in its density of traffic citations. So even without the legend, if I were to ask you where are the most traffic tickets issued in Redlands, you agree you'd probably pick the darker colors? Even without thinking of why you would say that, most people might come to that conclusion. And that would be darker colors to most people tend to implicitly suggest more of something. As do larger dots. There's another thing on this page. And then above all those little tips that I've mentioned is the darker colors and bigger dots also draw attention to the most important thing on this map. This is a map of traffic citations. So that makes traffic citations the most important thing on the map. Other things should not obscure being able to see where the traffic citations are. That's a mistake people often make, when making a map, and especially when you're new and you have all this data. I want to show off all this GIS data. How am I going to add it all to the map? And then you start adding, maybe there's parks, locations of importance, waterways. You add them all to the map, and that's great. But suddenly you can't see the traffic citations anymore. That data ends up taking away from the purpose of the map. Does that make sense? Another standard conventions allow us not to, or don't confuse the viewers. This is a temperature map. And if I asked you where it was the warmest, you might be able to answer just based on your knowledge of U.S. geography. But even barring that, most people would indicate that the warmest states are Texas and Florida. Now, this is a convention just applying to weather and temperature. But we all, at least in Western cultures, associate warm color. Well, look how we even name the colors. We even name colors in the orange and red spectrum as warm. So that shows you how ingrained that is in our culture. So you're not going to represent warmth with cool colors and cold temperatures with warm colors. So we represent coldness in temperature with cool colors, which would make sense, doesn't it? Blue, which are blues. In Eskimo, Northern, and Inuit cultures, I'm told it's actually the opposite. I think it has to do with the fact that ice may be bluer when it warms up. In the Inuit culture, they associate blue with warmth and red with cold. So if you had a temperature map in that culture, you would actually do the opposite in that case. So that's a reminder your map should be culturally sensitive to assist the viewer in looking at that. Some conventions change. This is a new one. In the United States now we talk about red states and blue states, where we talk about red counties that will vote for Republican, blue states vote Democrat. I found that is a very new phenomenon. In fact, I think they've gone up and updated these. Yeah, they have. I can't find any. Here's one. This is an older map from the 1960 election, the John F. Kennedy one, showing Democratic states in red and Republican states in blue. If you were to use that color scheme now, you would confuse, especially if your map readers are politically astute, you would confuse them. It's become, in political map making in this country, it's become a convention to color areas leaning to the right, the Republican side, red and blue for Democratic side. That has only been since 2000. And this may be the bonus question I still have to think about. This was started here in Buffalo by Tim Russert. I don't know if Tim Russert, who unfortunately has left us. He died of a heart attack. Was a commentator on NBC News for years. He's from Buffalo. And he first mentioned red state, blue state in the 2000 presidential election, Al Gore versus George W. Bush. And it just caught on. So the whole red state, blue state phenomenon actually was started by a Buffalonian. Last year I used that as the bonus question on the third test. We'll see if I do that as the same. It was started right here in Buffalo. So if you were to flip that now, you might confuse people. So that's an example of a cultural phenomenon that's very new. But if you go to your job and you're making political maps, it's advisable to stick to red for the right, blue for the left in this country. But just this country. In Canada, actually, the NDP and the Liberal parties are drawn in red. They associate, those parties are to the left, and while they're far from communism, some people associate the color red with communism. So on maps in Canada, they draw the more left-leaning Liberal Party with red, and their Conservative Party is drawn in blue. So that's a cultural phenomenon restricted, country by country.
What's the name of the person?
Tim Russert. And so that might be Yeah, for those that stepped out, that could be the bonus question. That Tim Russert was the inventor of the. Tim Russert invented the whole red state, blue state phenomenon I was going to say not long ago, I guess 2000 is 15 years ago, isn't it? Moving along again.
In Buffalo, wasn't it?
Yeah, he was a Buffalonian because he always had, not everyone here. How many people are from Western New York? Oh good, I'm glad to see so many. We like to brag about everyone in Buffalo, don't we? Except if it's O.J. Simpson. There's at least half, I think, were from Western New York. So we're all proud of Tim Russert. And he would, if you watch the program, he would always have a Buffalo Bills coffee cup. And he would give the presentation. So it was during that 2000 election when George W. Bush edged out Al Gore where he mentioned the red state, blue state thing, and it just caught on. And it's being used to the point where I showed the one map where they were reversed, but just a couple of years ago you could find a lot more that were wrong. People are actually going back and updating the older maps to adhere to this cultural phenomenon that is newer, only since the year 2000. And it's not, I shouldn't use the word wrong. A map showing Republicans in blue and Democrats in red is not wrong, but it would be confusing because it's not what the user expects to see. Does that make sense? So cultural things like that are things that you need to consider when map making. Along that same lines, call attention to the desired area of interest on the map with a darker or redder color in some cases. Again, if I were to say, what property is this, everyone's going to point to that. You don't want the user trying to figure out. If you're trying to call attention, this is also a Redlands website where you can look up. It's in Netscape, so it's probably not recent. Does anyone know what Netscape was? Really? Please wait. Okay, thank you. I am getting old. Only a few people. Netscape was a browser before Chrome and Firefox and all that. So this is a Netscape ArcGIS site for the city of Redlands that shows you're supposed to be able to look up a property. This information is related to specific properties. You don't want the user having to try and figure out, which property is this? And I think they did a good job. That's why I posted this. I think this map is pretty clear when you agree which property this is about, with the bright red there. And so this slide will tie into what I'm going to talk about in a couple minutes. And we call it background, foreground. Every map has a background, foreground. There's the part of the map that should stand out. You still do need other stuff on the map. The other stuff is a background. The foreground, the most important data on your map should always be in the foreground. And I think this map that they put together, I think they did a good job at that. So let's talk about colors. We have a similar concept with lines. And to illustrate this, on this slide I just copied a screenshot of Google Maps. On a street map, there's streets that are more important, major thoroughfares more people are going to drive on. They're wider highways. So note that obviously Google, and this may seem obvious, but I think it's worth noting, Google drew them in a thicker color, in a thicker line with a darker color. The interstate highways shown here are drawn with a thicker line and a darker color. The city streets are drawn with a thinner line and a lighter color. So they tend to stand out. In this particular example, the 47681, I would consider being in the foreground. And the other thing, they have some other things in the background, such as side streets, parks, lakes, and so on. Make sense? All of those things are variation. We're varying line width, we're varying color, and so on. So here are some of the things that we can vary. We've talked about all of these things. Well, some of these things we'll talk about more as we wrap up. Varying color, I mentioned a bunch of different examples already. So these are ways that we can vary symbols on maps to illustrate our point. You can vary color with a culturally appropriate color or a darker color. Even within the same color scheme, you can vary lightness or darkness. One this is a great, I found it. This example varies not only hue, but lightness or value, the second thing in that bullet list. And what this map shows is not just whether the county voted for, in this case, Mitt Romney versus Barack Obama, but the color illustrates how solidly that county was voted for either side. So we don't just, these two counties in Texas both voted for President Obama, but we could tell that that county voted for him with a higher margin than that one. We varied so we varied hue. Red and blue is a varied hue to indicate the person that won the county. But the value then is also used, it's called a bivariate color scheme, to indicate the proportion that it was won. And going back to how I described darkness earlier, the darker color indicates the person won the county in a greater landslide. So the very dark red solidly voted for Mitt Romney in the election, where the very dark blue colors solidly voted for President Obama to be reelected. And then it makes sense where you see where all the election campaign. I mean, in this country, it really boils down to the swing areas, because there's so many areas in this country that have their mind completely made up, one way or the other. The swing areas where the election was very close are in a very light blue or a very light red. So the very light blue areas just barely voted for the president, whereas the very light red areas just barely edged out towards Mitt Romney. So this is a great example, I think, of varying hue and value. The two top things, the two top bullets on our list. The shape of a mark, we talked about that a little. That tends to be more towards points than lines, but you might indicate the capital of the state with a different shape. There's a way of varying shape. You would draw Albany, for example, with a different a star is a typical thing that you see to indicate that that's the capital of the state. Or in one of the traffic ticket map, just like darker means more in a polygon, a thicker line means more on a line, a bigger dot is more. So the areas that had the most traffic citations had the bigger dots on that Redlands map. In a population map, I think Google will do this. They're not helping me well. These aren't very helpful. Well, sort of is. Because New York is drawn with a bigger dot than Newark to indicate that New York has a greater population. That's not as dramatic as I'd hope. You can kind of see that. Or Toronto has a bigger dot than Buffalo, although it's kind of slight. Detroit versus Ann Arbor and so on. If you were to make a population map of New York State, and you made a little tiny dot for New York City and a big dot for Lockport, or Utica or someplace like that, that might confuse your map reader. So that's where varying the shape, and by shape I'm talking about both the size and actually a different symbol, like the star for a capital, is something that you can use on your map. Directional range, we'll talk about location and orientation and spacing on a couple other slides as we move towards wrapping this up. A map is not just the map itself, but a map has, I alluded to this, map components that are associated with it. And you'll recognize that from the layout in labs where you've worked with a map layout. But obviously some of the professors use the fancy term called marginalia because they tend to be in the margins. But some of these other map components I'm talking about that are just as important as the map: title, legend, north arrow, scale bar, along with any other potential information about the map. Those are called other map components that are just as important. You never make a map, or you should never make a map unless there's a specific reason. It's just the map. Your map always includes this other information. What good is this map if I don't know what the yellow means? I mean, I still don't know what it means, I can't read that, but that's okay. Or even taking a step back, a title. Would anyone know that that's plant hardiness zone without the title? You might recognize it. When you buy seeds, it'll have that on the back, because every plant is adapted to grow and will do well in different climates. And then, what do the colors mean? We have a legend indicating what the symbology that you've chosen on the map means. We have a north arrow. Usually north is up on a map, but not always. I've done maps of runways where say for an airport, where it's north, the runway goes northwest, southeast. Sometimes we'll rotate to fit more of the runway on a piece of paper. So in that case, north isn't up. So a north arrow is critical. And then a scale bar, so that you know all this from lab, so that you can get a sense of what distance on the map represents in the real world. Another point on this slide is to balance this out, and this is where it becomes more of an art question. You wouldn't crowd all these things into one corner and then have the other corner of the map white. So balancing the features visually, which this map does a good job of, is an important thing to consider in cartography. So some final components, any questions? Some final components of map design that we'll talk about, and then we'll be done, are listed here. Clarity, and I've hinted at clarity and legibility. This is it's hard not to stress this enough because this is a problem all the time. Is the map readable? Not just readable, I mean that's a question in itself, but at the appropriate scale and distance. I stole this from the GIS course that I take from the SRI because I thought this was great. Here's an example of someone labeling everything. And it's taking maps of different features in Yellowstone Park and making a map of campsites, but they added road names and mountain peaks, and these are GPS monument locations. It's not readable. Too TMI, and too much information. So that's a definite example of the map not being readable. And if the map's not readable, it's not useful. Think about what the map, whether it's foreground or background, think about what is required to get your point across. Add those things to your map and nothing else. Don't add things to your map that aren't necessary. So that's a common, I'm sure I've done it too, it's a common mistake. Is it readable at the appropriate scale and distance is another thing that I think can be easily forgotten. We have, one of the things you do if you work in the environmental field, we'll do public presentations. If someone wants to build something new, they want to build a pipeline, they want to develop on the waterfront or something like that. So they hold public hearings where the public gets to come and voice their opinion about the project. So at the public hearing, oftentimes there'll be a poster. I thought about this. like bring this in to show you. You bring a poster and put it up on the wall in the front for the speaker to point at. We will make handouts to distribute to the people in the audience. Often those two maps, even though it's the same thing, we might use different strategies. Even though it's the exact same map, even the same purpose. Because on one hand, the handout, the person's going to take it home, they're going to have it right here. So you have a little more leeway. The one on the wall, you're going to have to look at from a distance. So in this case, text better be huge. You have to think about, you can't use as much text. Because even my eyes are 20 or 25 years older than me, they're starting to go. But even for someone with perfect young vision, you're only going to be able to see text that's big enough if you're looking in an audience from a distance of 20, 30 feet, or maybe up to 100 feet. So limit the amount of text. Or if you do have text on the map, it better be really big so that the person way back in the back row back there can read it. On the handout, I don't have to worry about that because people, I may hold it like that, but people can look at it and see more text, they can see more detail and find features. So when we work on a project like this that involves a public meeting, we will actually create two very different looking maps that actually do have the same purpose. It's the exact same map, but it'll look the handout will look completely different sometimes than the one hanging on the wall. Does that make sense? And in that case, the sole reason for the difference is the size and location in which the map will be presented. Same goes if it's a PDF that someone's going to upload to an internet website about the project. You have a lot more leeway because people might download the PDF to their computer and zoom in. So in that case, you also have a lot of leeway to present a lot of detail because a person can look at the map on their computer screen and zoom in very close versus a situation where you're going to have to show something to someone from a distance where you won't have that. That makes sense? So think about how the map is readable, but also think about how you're presenting your map physically. And that's something you should think about too from the beginning. I talked about when you start, think about the purpose of the map. Thinking about how you're presenting the map is also something you should be thinking about from the beginning. And hopefully that example I gave illustrates how that could radically affect the output of your map, is how you're going to show it. Visual contrast between colors. It's not just, I mentioned darker versus light colors, but the colors also should stand out from each other. And this especially applies to qualitative maps where when you use random colors. Remember that question from test 1? Where when we're doing a nominative or qualitative data, we tend to use a random color scheme. Make sure the colors contrast with themselves well. I found these are congressional districts in North Carolina. I found two different maps of the same thing. I think this map contrasts the district much better than this one. It's very hard to distinguish District 2 from District 9 here. And even District 7 kind of blends in, and so does this. There's not enough contrast between the colors on this map that I found. This map does a better job. And even where the average person can only distinguish about 7 colors, and on a map after 7 colors, you start to have to pick colors that are similar. But at least what this person did is, okay, I have to reuse yellow. They at least picked 2 things that are yellow that are adjacent to each other. So even though 4 and 10 are pretty close, it's easy to tell them apart because they're not next to each other. Another interesting thing that I learned in cartography, obviously every single person's different, but females on average can distinguish about 3 times as many color as men for some reason. And obviously there's a lot of variability in that. Also, I have another slide, but this is another way to illustrate, and I've talked about this. So visual contrast and balance. We talked about the contrast. Though I don't like the contrast of the colors, I think the balance on this map is okay. Let's spread out the title, overview map, and so on this well, I think, but balancing the map is important. This also talks about that foreground, background concept that I mentioned. Another way you'll see that mentioned is figure versus ground. So when I say figure here, I'm talking about the foreground, and when I say ground, I'm referring to the background. So here we have North Carolina is the focus of this map. So it is in the foreground. They've done a good job with that. But we don't want to just show North Carolina as an island in the universe. They wanted to display its relative position in the states. So we have its adjacent states, and we have the Atlantic Ocean map also to show North Carolina's location. But they've done a good job of making those the background. North Carolina still stands out. And that's an example of figure versus ground. Items should balance. It's almost like a centroid of a polygon. Items should balance on the optical center of the map, which is, I'm not even sure why, it's slightly above the geometric center. I'm sure there's a reason for this. I think it's how people look at a page. They look up above that a little bit. So if you visually look at all the items on the map, the busyness versus the white space of the map, it should balance out to the optical center slightly above the middle of the paper. Here's another example of figure versus ground. And I like this because I've seen a lot of poor quality maps that don't adhere to figure versus ground. I probably made some myself. But I like to stress this, and I'm sure to have a question about figure versus ground or background, foreground. But just to stress that, again, the important part of the map should be on the foreground. And we learned, over the last hour, we learned about a variety of techniques to make sure it's in the foreground, the color, the symbols, and so on. So this is an example, it's disappearing fast, but the Ogallala Aquifer is a good source of water in the Midwestern United States. It's drying up, which is not a good thing. Here's a map of the Ogallala Aquifer, and most importantly, maybe the reason it's drying up, where it is located over or below agricultural land, where people are irrigating with it. So that's what we want to show in the map, and this map does a good job of bringing that in the foreground. The state boundaries are in the background, they're just in outline. In fact, the states are all just in white. The only shaded polygons in the whole map are in reference to the aquifer. So if we had done something different where the states are all in different colors, that might obscure the location of the aquifer. So this is a good example of figure versus ground. I like this one because it's opposite of what you often see in a map. We see many state maps where the states are the primary focus and the lakes are kind of just there. This is a map showing, I think it's fishing spots and recreational spots. Mass balance study or organisms in Lake Michigan. So in this case, the focus is Lake Michigan, not the surrounding states. So the lake itself is in a darker color, the symbols are within it, and the land is drawn in a lighter yellow color. And note how the lake is been placed in the optical center of the map too. Whoever did this, so the US EPA made this map. They placed it on the map slightly above the optical center. So they even adhered to that rule of slightly above optical center when EPA made this. So when I found that, I saved this. That's what I'm going to show. So background is important. I'm not saying don't have a background, but a background, you have to be careful to not have it obscure the primary focus of the map, which should appear in the foreground. Are there any questions? That's the end of the lecture. We'll take a very short break. I want to start up maybe 5 minutes, 10 at the absolute most, and then we will do presentations. Oops, and I never.